And under decimals, the little subheading is comparing and ordering. Comparing / ordering them. And you just have to be a little bit careful with decimal because, you know, sometimes the way you think about numbers is not necessarily true with decimals. For example, here's an example. If I asked you to compare 12.3 to 1.23, 12.3 to 1.23. If you step back and you look at that, you go, oh, look, they both have a 1, a 2, and a 3 in that order, so they're equal. You may end up with a little bit of trouble because these numbers are not equal. You know, the first thing you want to do when you're comparing decimal numbers is look at the whole numbers, if they have a whole number. Because if I look at the whole number, I can stop right away, simply because 12 is by far bigger than 1. It doesn't matter what comes after it as far as the decimal goes. 12 is going to be bigger than 1, so you could stop right there and say, okay, that is greater than that number. Are you picking up what I'm laying down on that one?
Yeah.
I thought so. Let's look at another one. What about this one? Compare 6.7 to 6.35, which, if you look at those, just looking at it quickly, you might say, well, this has 3 digits, it's 635, and this only has a 6 and a 7, that must be bigger or whatever. That again is not necessarily the case because step number 2, okay, when you compare decimals and their whole numbers are equal, when the whole numbers are equal, like they are in the last one here, when the whole numbers are equal, what you really need to do, you need to look at the decimal digits one for one. And I'll explain that in just a second here. Hopefully you'll catch on to this here. Picture's worth 1,000 words, then why can't I paint you? So here we go, looking at this. These both have 6s. So the whole numbers don't tell us which one's bigger, or if they're equal or whatever. So you look at the decimal, and you just start off looking at each digit to the right of the decimal. This is a 7. The first digit after the decimal is a 3. 7, in my mind, has always been bigger than the 3. So you can stop right there because it doesn't matter what happens after this 3. This 7 in the 10th place is going to be bigger than anything that comes after it with whatever. The 7 is bigger. Another way to think about it, ladies and gentlemen, is this. How many digits does this have to the decimal? 2. You can always add zeros at the end of decimals. I could put a 0 here, so it also has 2 digits after the decimal. And what comes after the decimal here is a 70. What comes after the decimal there is a 35. 70 is going to be larger than that. Example number 3. If you have this 14.2 compared to 14.200, those, if we follow our simple little rules, the 14s are the same, the 2's the same, But what about those zeros there? Frankie?
The 14.2 is greater.
The 14.2 is, did you catch the thing? And I said you can
equals
always
zero.
add zeros. Thank you. You can always put as many zeros as you want on there. These two things are the same thing. 14 and, by the way, if I read these decimal wise, 14 and 2/10 is the exact same thing as 14 and 200 thousandths. They're the same thing. Usually, zeros at end of decimals, we actually usually leave those off because they tend to confuse us a little bit, but they are there. Now, what about ordering decimals? Let's look at a problem with ordering and see if we can't come up with some sort of strategy to figure this all out. Let's say you're supposed to put these in order. 1.02, 1.02, 1.12, and 1.2. If you're going to put those in order, Andrew, would it help if you sat in the front row? That you don't. Are you with Colton? Is there some sort of what's all the eye contact going on here? Is there some sort of no? Maybe what would help is if you put your little posterior on your chair. Let's go with this rule here. Your posterior on your chair and both of your knees actually under your table. You and Andrew can, or you and Colton can converse at one time all you want. But right here, I'm sensing a slight blank of focus. Colin agrees with me. He wasn't even looking at you. Now I lost. What was my place there?
We were putting the decimal.
Oh, decimal in order. What would probably be the smart thing to do on this is to make sure every number has the same number of digits after the decimal. See, this has 2, this has 2, this one has 1. But maybe it would be helpful if you stuck that one there just because it makes it easier to tell. So then, using the same rule, they all have 1s as whole numbers, so you can't tell what's the biggest. What is the smallest number? Well, now you're looking at 0.02, 0.12, and 0.20. Which one is the smallest of those three? Nathan?
0.02.
Right. So the first one you're going to write down from least to greatest is 1.02. Then you're left with 0.12 or 0.20. Which one's the next biggest? Addie?
1.12.
Yeah, 1.12. Apparently I wrote them down in order as I started, didn't I? And then the last one would be 1.2. Now when I read the answer, I'm not going to read it with this 0 that you put in there to see. I'm going to read it with what they gave you there. Let me try a harder one that isn't all in. All right, you about ready? I'll find it. Don't you worry. A real stumper, I like to call it. 2.4. I'll let you order these. 2.4. 2.04. And 2.21. God bless you, one and all. I will give you, 16.5 seconds to put those in order from least to greatest for me. Smallest to biggest. By the way, make sure you always read direction, because every once in a while, the book will tell you to put it from greatest to least. Usually it's least to greatest, but you always want to make sure you're reading some direction. God bless you again and again. Jacob Bauman, which one is the smallest?
2.04.
Correct. And again, I would put that 0 in there just so I can see it. Small, 2.04, 2 and 4 hundredths. Next, then, would come what, Jordan?
2.21.
2.21. And then the biggest number would be that 2.4. Ladies and gentlemen, this ends the